So in 11b, we're doing transformations of exponential functions, which means we want to investigate our exponentials a little bit more, and we're going to be drawing some exponential graphs. So the first question, we just want to use our calculator to find the value of these expressions here correct to 4 significant figures. So on your calculator, the E button you find by pressing Shift and then LN. We want E to the power of 3. Okay, to 4 significant figures, that will be 20.09. Okay, for the second one, we're going to use our fraction 1 over square root of E. So we need to press Shift LN for E. Because there's no power there, we need to put in a power of 1 and we press equals. So that is 0.6065 to 4 significant figures. Question 2 is all about sketching, and we want to use transformations, which means we're going to be moving our graph left and right and up and down. So from our basic exponential graph, which is y equals e to the x, now just a reminder that that graph very, very roughly looks like this. So exponential means it's coming up very, very steeply. The intercept here is at 1, and there is a horizontal asymptote down here on the x-axis. So that would be horizontal asymptote at y equals 0. Okay, so we want to take that graph of y equals e to the x, and we're going to be moving it around, but we need to make sure that we always show the y-intercept and the asymptote, and we want to also state the range. So the first one is y equals e to the x minus 2. So the only thing that we've done is add this little minus 2 on the end, which means that we've moved the whole graph down 2 places. So drawing up your Cartesian plane, the horizontal asymptote needs to get moved down 2 places. So it is now down here at minus 2. So don't forget to write the equation on the side. Horizontal asymptote is y equals minus 2. Now we can also move the y-intercept, which is normally at 1. So normally it's up here at 1, but it's also going to move down 2 places. So 0 and then minus 1, that's where that point is going to move to. If you're in any doubt, all you would need to do is substitute x equals 0 into your equation here, and you would get e to the power of 0, which is 1. 1 minus 2 is negative 1. Okay, so even though this question didn't ask for it, some questions will ask you to also show an extra point so that you can show the steepness of your exponential graph. So this is when you just choose another value. Normally 1 is a good value to sub in, and we substitute that into our equation. So if I sub in when x is equal to 1, I get y equals e to the power of 1, which is just e, minus 2. So e to the power of 1 minus 2, let's just find out what that is. E to the power of 1, and then minus 2 on the end. That's equal to about 0.7. So at 1, we're at about 0.7, which is about there. And now we have the steepness, and we can draw our exponential curve. Make sure that your exponential looks like it's always going to keep approaching that asymptote. It shouldn't look like it's going to come back up at all. It's got to keep approaching like that. You should write the coordinates of the extra point that you found next to it over here. So that was the point 1, and we usually like it in exact form. So that was 1, and the y value was e minus 2. Okay, so we've drawn the graph. We have to state the range. The range is talking about the possible y values. Now, if we look at our asymptote, our graph has to stop at y equals minus 2, so the y values must always be greater than minus 2. Can't be equal to, so don't put an equal to sign on that, because it will never actually hit that asymptote. so greater than -2. All right, part B, let's draw the next one. Y is equal to e to the power of -x. The difference in this question is that little minus sign on the power of x there. What is that going to do? Well, it is going to reflect the graph over the y-axis. But let's investigate that as we draw it. So first of all, there's no number on the end. We haven't added or subtracted anything on, so the horizontal asymptote is not going to move. So let's draw that on there. Here it is in its original position, horizontal asymptote at y is equal to 0. If I were to sub in x equals 0, e to the power of -0 or e to the power of 0 is still equal to 1. Okay, so that is unchanged from the original graph. Let's check what happens if we sub in another value. So let's sub in our x is equal to 1. That would be, so I'm going to write it here, when x is equal to 1, I get y equals e to the power of -1. Now, as a value, e to the power of -1 is equal to, let's say, 0.4. We really can't be any more accurate than that on our graph anyway. So at 1, 0.4 would be about there. So it means we can see that our graph is going to be starting off really big and coming down really small and approaching that asymptote. If you find an extra point, don't forget to label it. That point was the point 1, and in exact form, the y value was e to the -1. We also need to include the range. The range, looking at that asymptote there, the y values are all going to be larger than 0. Part C, we have y is equal to e to the power of x plus 3. So what is that x plus 3, that extra number in the power, going to do? Now, if it's all combined up there in the top of that power, it's like having it in brackets, which means that's going to move our exponential from side to side. And remember, it moves it in the opposite direction. So if it's a plus 3, it's going to move it 3 spaces to the negative side or to the left. So let's draw our Cartesian plane. My asymptote has not been moved. I haven't got anything added on the bottom there or subtracted. So it's still sitting here at horizontal asymptote of y equals 0. But my point, my intercept, which is normally at 0, 1 here, is going to move 3 spaces left. So 1, 2, 3, it's going to be at -3, +1. So there is where it has moved to. And I'll write that point on there. That's the point, -3, 1. I need to find my y-intercept, which means I'm going to have to sub in when x is equal to 0. And that is y equals e to the power of 0 plus 3, which is just e to the power of 3. If you type e to the power of 3 in your calculator, that's approximately equal to 20, just to tell you how steep it is. It's going to be really, really high, way up here. So I put a little mark there, and my curve comes up very steep like that. I'm going to put the exact value on here. That's e to the power of 3. So I have got my graph drawn, but don't forget to include the range. The range is still y greater than 0. And one last one, part D, we have y is equal to 2e to the power of 1 minus x. So we have a 2 at the front of that, which is going to change the steepness. And the 1 minus x is going to move it sideways 1 place, and it'll be 1 place to the positive side, to the right. But because there's also a minus in front of that x, it is going to reflect it across the axes as well. So we have a lot of things happening here. The asymptote, however, has not been moved. So at least one thing stays the same. So let's start with that asymptote right here. Horizontal asymptote at y equals 0. Because lots of things have changed here, you'll probably find it easier if you sub in a few values. So we know we need the y-intercept. So let's sub in when x is equal to 0. That's going to give us y equals 2e to the power of 1 minus 0, which is just 1, so it's just 2e. 2e is approximately equal to 5.4. Okay, so just to tell you whereabouts to put that. 1, 2, 3, 4, 5, 6. So 5.4 is going to be about there. I'll put a little mark in there. That is e to the 2e. I need another point as well, so I'm going to sub in when x is equal to 1. If I sub in x equals 1 into my equation, I get y equals 2e to the 1 minus 1. 1 minus 1 is 0. E to the power of 0 is 1, so that's just 2 times 1, which is 2. So 1, 2. There is my second point, and you can see here comes my exponential graph, which is going bigger to smaller, so it has been reflected, moved sideways, and made steeper. Just don't forget to label this point here. So it's 1, 2. The range of this last graph is still y is greater than 0. Okay, so that's it. You need to have a look at the questions in exercise 11b.